Okay, welcome back, students. We're going to be covering 3.2, applications of radian measure. Okay, so for the application, one of the applications of radian measure is arc length, which is different than arc measure. Arc measure is just your degree measure, but your arc length is actually it's a piece of circumference of the circle. Okay, and so we find that by calling it S. The length of an intercepted arc on a circle is given by S equals R, the radius times theta, and theta is in radians. Okay, so if you multiply theta times theta in radians times the radius, then you get the arc length. Okay, and this comes to us from the circumference. Okay, the circumference, the circumference is equal to 2 pi r. Okay, if we go all the way around the circle, the theta is 2 pi. And so what we do is we just say, well, if the whole circle is 2 pi, which is theta, okay, then any piece of the circle, any part of the circumference is just going to be theta times r. Okay, theta. So you take your fractional amount because pi, if you did pi, it would be half the circle. If you did pi over 4, it would be 1/8 of the circle. Okay, so anytime you just put the theta, the degrees in the angle measure in radians and multiply it by the radius, okay, this r, and you will get the arc length. Okay, so we have 7 pi over 8, and the radius is 25.60. So we want to find the arc length here. So it's just as easy as going S is equal to R times theta. Okay, this is 25.60 times 7 pi over 8. Okay. And so we're going to say that S is approximately, plug this into my calculator, 25.60 times 7 pi divided by 8. And I get 70.37, and I believe the units was centimeters. So 70.37 centimeters. Okay, for my first example there. Okay, let's try the next one here. Same radius measure, but the angle is different, and the angle is in degrees, and so we want to put this angle in radians. So let's take 54 degrees and multiply. Again, what do I want to end up with? I want to end up with radians, so that's pi radians on the top and 180 degrees on the bottom. Okay, so this is going to be 54 pi over 180, and that reduces to, I think I can divide both top and bottom by 18, and so this becomes, this is equals 3 pi over 10 radians. Okay, so now I have my angle theta in terms of radians, and now I can find the arc length by just multiplying that by the radius, which is 25.60. So we're going to multiply this out, and we'll end up with S being approximately, okay, 3. Let's do 25.60. Oops, decimal point. 60 times, and then that was 3 pi over 10. 3 pi over 10. And we're at 24.13, I would say. Okay, so 24.13 centimeters. And what is this telling me? It's telling me that this measurement from A to B, if I were to make that a piece of string and then measure that piece of string, that piece of string would be 24.13 centimeters long. Okay, it's not quite R. Okay, 1 radius. Okay, it's a little less than 1 radius, but it is the arc length. Okay, it is the arc length. Okay, and the same with example A. This thing here ended up being about 70.37 centimeters. That's the arc length. Okay, that's the distance I would have to travel around that circle to get from point A to point B, or vice versa. Okay, example 5. Okay, Erie is approximately due north of Columbia. Okay, the latitude of Erie is 42 degrees north, and the latitude of Columbia is 34 degrees north. And I looked this up, and I think it's Erie, Pennsylvania, and Columbia, South Carolina. They're not talking about Columbia, so these are both cities in the United States. They're not talking about Columbia, the country in South America, okay, or Erie, the lake, near I think it's Wisconsin. But this is Erie, Pennsylvania, and Columbia, South Carolina. Those are the latitudes. What is latitude? Well, if we look at the whole Earth, okay, the latitudes are the lines that are flat. Okay, one line of latitude is the equator. Okay, that's the largest latitude. It's at 0 degrees. It's at 0 degrees latitude. Okay, and so they're saying that the latitude of Columbia is 34, so we'll go 34 degrees, and the latitude is 42 degrees. Okay, so these are all degrees of latitude. Okay, and it goes from 0 to 90. 90-degree latitude in the northern hemisphere would be the North Pole. So this is 90 degrees, right? And so we're saying we want to know the distance that Erie, Pennsylvania is from Columbia, South Carolina. Okay, and so that's an arc length. That's an arc length, and they're saying the radius of the Earth is 3,959 miles. Okay, or whereabouts. Okay, it depends on exactly, where you are on the Earth. But that's an approximation. Okay, a good approximation of R. So we just need to know, okay, well, what is the angle made between Erie, Pennsylvania, and Columbia, South Carolina? So that angle, if I'm going to blow it up, okay, that angle, again, 34 degrees to 42 degrees, that is going to be 42 minus 34, and that's 8 degrees. So that's an 8-degree angle. And they're saying the radius here is 3,959, and so S is equal to theta times R, but theta needs to be in radians, right? So I'm going to say, okay, well, this is going to be theta. How do I convert the 8 degrees to radians? Well, again, that's going to be pi over 180. Okay, and I think 180 is divisible by 4. I don't think it's divisible by 8, but I think it's divisible by 4. And so this becomes 45 on the bottom. So this is equal to 2 pi over 45. Okay, so that's my radian measure, is 2 pi over 45. I'm going to plug that in here. And the radius of 3959, I'm going to plug that in there. And so S is equal to, and this is going to be the distance from Erie, Pennsylvania to Columbia, South Carolina. This is going to be 2 pi over 45 times 3959. Okay, and so S is approximately, let's see, let's go to the calculator, 2 times pi, okay, divided by 45 times my radius of 3959, and I plug that in, I get about 552.78 miles. Okay, so about 552.78 miles is the distance between those two cities. Okay, two gears are shown below. If the smaller gear rotates at an angle of 150, okay, so the smaller gear rotates at an angle of 150. So we'll say from here to here is an angle of 150, this point to this point. Through how many degrees does the larger gear rotate? Okay, so through how many degrees does the larger gear rotate? Okay, so they're both going to be moving the same distance. Okay, they're both going to be moving the same distance, but they're going to have a different angle measure because of the size of the radius. Okay, so we know that S times theta is S is equal to R times theta. Okay, so we want to know what's this angle measure. Okay, S is equal to R times theta. Now there's two ways to do this problem. I'll show you the hard way first, which is the way that they want us to do it, and then I'll show you the easy way, which is, you know, kind of a cheat, and not the way they want us to do it, but it's okay. So the way they want us to do this is to say S is equal to R theta. Okay, we know this is 150 degrees, and they want us to convert our degrees into radian measure. So 150 degrees becomes the pi over 180. Okay, both top and bottom are divisible by 30. So this becomes 5, and this becomes a 6. So this is 5 pi over 6, which is 150 degrees. Okay, now we're going to say, well, 5 pi over 6 times 150, or sorry, not times 150, times 3.6. Okay, I'm just going to leave this in terms of pi. Okay, is equal to 5 times 3.6 is 18. And then we want to divide that by 6, and we get 3. So when you do the calculation here, 5 times 3.6 divided by 6, you're going to get 3 pi. Okay, so this whole measurement here, this whole length, let me put it in a different color. I'll put it in black. Okay, this length here is 3 pi. Okay, 3 pi inches. Okay, and so this guy here is also 3 pi inches. It's going to have to go through the same angle. I mean, not through the same angle, through the same arc length. So this guy was 3 pi, and this guy over here is 3 pi because they're going to be moving together in sync. Okay, but we know that S is equal to theta times R. Okay, and so what is the S in the larger gear? The S in the larger gear, that's 3 pi. What we're looking for is theta. The R is 5.4. Okay, and so if I divide by 5.4, okay, I get 3 pi over 5.4 as theta. Okay, And then I want to change this to a degree measure. Okay, back to degrees, which is going to be 180 over pi. So what's nice is the pi, I get rid of that. I can multiply 3 times 180 and then divide by 5.4. So 3 times 180 divided by 5.4 is 100 degrees. So this thing ends up being 100 degrees. Now this is the way they wanted us to do the problem and say, oh yeah, we found that this one was 100 degrees. Okay, now the cheap and easy way to do this is to not convert to radians, to just keep it in degrees. Because again, if I know S is theta times R is equal to theta times R, I don't have to necessarily convert 2 radians from degrees to go back to radians and then go back to degrees. It's kind of like we're doing stuff in reverse. Okay, in this specific case, we can just say, well, there's a ratio here of 3.6 to 150 is 100 to 5.4. Now, does that make sense? That 3.6 times 150 is equal to theta times 5.4. You know, I don't know what theta is, but I want to keep things in degree measure. I don't have to go from degrees to radians and then from radians back to degrees. If I just keep this in degree measure and this will not give me the arc length because it's not in radian measure, but I don't care because I'm not trying to get arc length. I'm trying to get the degree measure. Okay, so this is going to be some value in degrees, you know, degree, what is it going to be? It's going to be degree inches or something. I don't know. It's just craziness. Okay, but I don't really care about the units because at the end, if I'm going to divide by the 5.4, it'll keep it in degrees. The inches will cancel out. 3.6 inch and the 5.4 inches will cancel out, and it will give me my theta in degrees. Okay, so again, I don't know if I'm explaining this well, but if I just keep it as theta r equals theta r and keep theta in degrees, I can go from degrees to degrees. And I don't have to go through that intermediary step of radians. You can't always do this, so just keep that in mind. But in this specific case, you can. And so we get 3.6 times 150, and then divide that by 5.4, and you'll see we do get 100. Okay, so it was just, we didn't have to convert to radians to go directly to the degree measure in the other one. Okay, because it really is it's a proportion. Okay, so okay, so area, let's talk about area. Area of a circle, okay, is pi r squared. So if I just take the area of a circle, is pi r squared. That's for the whole circle. Now, if I let my theta be in radians, okay, what is the radian measure of a whole circle? Well, it's 2 pi. Okay, 2 pi is the whole circle. So I say, oh, well, this is pi r squared. So what I can do is I can take 1/2 of theta and multiply that by r squared, and that will give me the area of a sector. It'll give me the piece of right, because the whole circle is 2 pi, and I don't want 2 pi. I just want a pi for the whole circle. Okay, I don't want 2 pi. So what would I have to do if theta is equal to 2 pi? How would I get my pi r squared? Well, I'd have to divide that by 2. I'd have to take theta divided by 2. Okay, and that gives me pi. Okay, so theta divided by 2 is pi, and that's really what this 1/2 theta here is in my equation, in my formula. That 1/2 theta is really just the we're saying that 2 pi is a whole circle, but we don't want 2 pi, we want pi, the value of pi, because that's the area. And so we just cut that theta in half. Okay, we cut the theta measure in half, and then whatever fractional amount of theta it becomes in radians, I just multiply that times 1/2 and then multiply that by r squared, and that gives me the sector area, or the piece of the circle that I'm looking for. Oops. Okay, so if I'm looking for a little slice of this circle, okay, I can use the radian measure of the angle to give me the area of the slice of circle. And keep in mind that this is going to be square units because it's area. Okay, the units will be squared. Okay, find the area of the sector watered by the sprinkler. Okay, so we have 78 degrees. We'd like to change that to radian measure and then use the formula. So theta is equal to 78 degrees. Radian measure is going to be pi over 180. Okay, and I believe 78 is divisible by 2. And so this becomes 39 pi over 90, because I just divide both of these by 2. Okay, so that's my radian measure. Okay, radians. That's the radian measure of my circle. And so we're going to say for the sector area, this is a sector. A sector is a piece of circle. For the sector area, we're going to say that this is 1/2 r squared. What's r? 6.5 squared times the theta. But what's theta? Theta is 39 pi over 90. So I got to plug this whole thing into the calculator. Pray I don't make a mistake. And then get out what the area is approximately. Okay, so I'm going to say 1/2 times 6.5 squared times 39 pi over 90. Okay, and that equals 28.76. Okay, so let's go back here. This is 28.76. And what are my units? My units are square feet, okay, or feet squared. Okay, because it's area. The A stands for area. Okay, and I would encourage you, I know I go a little fast on these problems, I would encourage you to pause the video and you know, or go back, you know, rewind a little bit and make sure that you can go through this on your own and successfully do the problems. Okay. Okay, and I will see you in the next video.